Now, in this lecture, we'll find out the length of line segment MN. In the drawing, we have square ABCD. We know that one side of this square is equal to 12 units. That is to say, AB equals to BC equals to CD equals to DA equals to 12 units. And inside the square we have a circle and a semicircle. The circle is tangent to the square at 2 points. This is the first point of tendency, this is the second point of tendency, and also the circle is tangent to diagonal AC at this point, and the semicircle is tangent to the circle at this point, point D, and it is tangent, the semicircle is tangent to diagonal AC at this point, and it touches side DC at this point. And we want to find out, we know that the center of the circle is at point M, the center of the semicircle is at point N, and we want to find out the distance between the two centers. That is to say, we want to find out the length of MN. Okay? So in the first step, we define the point of tendency of side AB with this circle as point P. We define the point of tendency of side BC with this circle as point Q. We will define the point of tendency of diagonal AC with this circle, this point as point R. And we will define the point of tendency of diagonal AC with this semicircle as point S. And we will define the touching point or the intersection point of side DC with this semicircle as point T. And we will define line segment PB as A, and in the next step I will present to you a new rule. It is actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. according to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So if we have an external point, point P, this point P, is defined as an external point in relation to this circle. Why it is an external point? Because of the fact that point P is not located inside this circle, nor on this circle, but it is located outside of this circle. Therefore, point P is defined as an external point of this circle. So if from the external point, point B, we will draw two tangents to this circle. So here the first tangent will be this tangent. The point of tangency of the first tangent with the circle will be defined as point A. So actually the length of the first tangent is PA, and then we will draw a second tangent to this circle. So this is the second tangent to this circle. We define the touching point or the intersection point of the second tangent with this circle as point B, and the length of the second tangent is PB. So I'll read rule number 1 again. The lengths of two tangents from a common external point to a circle are equal. So the length of the first tangent is PA, the length of the second tangent is PB, and according to rule number 1, the lengths of two tangents, that is to say PA and PB, from a common external point, that is to say point P, to a circle are equal. That is to say PA is equal to PB. According to rule number 1, whenever you draw two tangents to a circle from a common external point, like in this drawing, then the lengths of those two tangents will be equal to each other. In this case, PA must be equal to PB. Okay, so here we actually can implement rule number 1 in our drawing. Because in our drawing we have here we have point B. Point B is defined as an external point in relation to this circle, and from the external point, point B, we have two tangents to this circle. The first tangent is tangent BP, and the second tangent is tangent BQ. Okay, from point B we have two tangents to the circle. The first tangent is BP and the second tangent is BQ. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, BP equals to BQ according to rule number 1. So, according to our definition, BP equals to A. So from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. Okay? can write here that BQ equals to A. So, what is the value of AP? It is very easy to see from the drawing that AP is equal to AB minus AB minus PB. Again, AP equals to AB minus PB. So, AP equals to AB, that is 12 units, minus PB, that is equal to A according to our definition. So in conclusion, we found out that AP equals to 12 minus A. We can write here that AP equals to 12 minus A. Likewise, what is the value of QC? From the drawing, it is very easy to see that the value of line segment QC is equal to BC minus BQ. BC minus BQ. That is to say QC equals to BC, that is 12 units, minus BQ, that equals to A. So in conclusion, we found out that QC equals to 12 minus A. QC equals to 12 minus A, so we can write here that QC equals to 12 minus A. And we will refer to point A. Point A is an external point in relation to this circle. From the external point, point A, we have two tangents to the circle. The first tangent is tangent AP. The second tangent to this circle from point A is tangent AR. And according to rule number 1, AP must be equal to AR. AP must be equal to AR according to rule number 1. But we have only found out that AP equals to 12 minus A, so we can write here that AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR, we conclude that AR is also equals to 12 minus A. We can write here that AR equals to 12 minus A. Point A is an external point in relation to the semicircle. From point A, we have two tangents to the semicircle. The first tangent is tangent AS, and the second tangent from point A to the semicircle is AD. And according to rule number 1, AS must be equal to AD. According to rule number 1, AD equals to AS. But it is given us in the question that AD equals to 12 units. You can write here that AD equals to 12 units. And from this equation, 12 equals to AD equals to AS, we will derive that AS is also equals to 12 units. AS equals to 12 units. So we can write here that AS is equal to 12 units. And what is the value of RS? It's very easy to see from the drawing that RS is equal to AS minus AR. Again, RS equals to AS minus AR. So RS is equal to AS, that is 12 units, minus AR, that is 12 minus R. RS equals to 12 minus 12 minus R. We will open the brackets here and we will get the 12 minus 12 plus R plus, it is actually 12 minus A. AR equals to 12 minus A. AR equals to 12 minus A. So here we have 12 minus 12 plus A. 12 minus 12 is 0. In conclusion, we found out that RS equals to A. So we can write here that RS equals to A. We will focus on point C. Point C is an external point in relation to this circle, and from point C we have two tangents to this circle. The first tangent to this circle is from point C is CQ, and the second tangent to this circle from point C is CR, and according to rule number 1, CQ must be equal to CR. I repeat again, CQ must be equal to CR according to rule number 1, but we have already found out that CQ equals to 12 minus A. We can write here that CQ equals to 12 minus A. And from this equation, 12 minus A equals to CQ equals to CR. We will conclude that CR is also equals to 12 minus A. Okay, here CR equals to 12 minus A. In the next step, I will present to you a new rule that will be rule number 2. According to rule number 2, according to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle, and we know that the center of this circle is at this point, point O, and we also have tangent to this circle, if AB is tangent to this circle at this point, we define this point as point M. Actually, point M is the point of tendency, point of tangency of this tangent AB with this circle. We join points O and M together by a straight line. OM is the radius of this circle. We define it as R because of the fact that line segment OM starts from the center of this circle, that is to say from point O, and ends at point M, that is the point of this circle itself. Therefore, OM is the radius of this circle. So here we have the radius OM. It is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to the radius OM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So whenever you have a radius that is drawn to the point of tendency, like in this drawing, then the tangent will be perpendicular to this radius. In this case, the tangent AB will be perpendicular to the radius OM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay, this is rule number 2. We can implement rule number 2 in our drawing. Here we will join points P and M together by a straight line. PM, line segment PM, is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and then at point P, that is the point on this circle itself. Therefore, PM is the radius of this circle. The radius PM, it is drawn to point P, that is the point of tendency of tangent AB with this circle. So whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to this radius PM. AB perpendicular to PM, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Again, according to rule number 2, a tangent to a circle, that is to say, tangent AB, is perpendicular to the radius PM. Why? Because the radius PM is drawn to the point of tendency. Whenever you have a radius that is drawn to the point of tendency, in this case it is drawn to point P, that is the point of tendency of tangent AB with this circle, then the tangent AB will be perpendicular to the radius PM. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And we also know that all the angles inside the square are right angles, therefore angle ABC is a right angle in square ABCD. So here a right angle, angle ABC is a right angle, we will join points M and Q together by a straight line. Here MQ is the radius of this circle because of the fact that it starts from point M, that is the center of this circle, and then at point Q, that is a point on this circle itself. Therefore MQ, it is the radius of this circle. And we have here the radius MQ is drawn to the point of tendency. That is to say, it is drawn to point Q, that is the point of tendency of tangent AB with this circle. And because of the fact that the radius MQ is drawn to the point of tendency, then according to rule number 2, the tangent BC will be perpendicular to the radius MQ. Again, the tangent BC will be perpendicular to the radius MQ. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So, in quadrilateral PBMQ, we have 3 right angles. Okay? We focus on quadrilateral PBMQ. In quadrilateral PBMQ, we have 3 right angles. The sum of 3 right angles is 90 times 3 equals to 270 degrees, plus the size of the 4th angle, that is actually angle PMQ. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, here we will subtract 270 degrees from this equation, and we will get that the size of angle PMQ equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle PMQ is a right angle, it equals to 90 degrees. So here we can draw a right angle PMQ is a right angle. We actually found out that quadrilateral PBMQ has 4 right angles. 1, 2, 3, 4. All of its angles are right angles. Any quadrilateral that has 4 right angles, it must be at least a rectangle. So we relate to quadrilateral PBMQ as a rectangle. Quadrilateral PBMQ is a rectangle. And we have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. I read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, rectangle PB and Q, the opposite sides are equal to each other. It means that PB equals to MQ, PB equals to MQ, according to rule number 3. but according to our definition, PB equals to A, PB equals to A. From this equation, A equals to PB equals to MQ, we will conclude that MQ is also equals to A. We write here that MQ is equals to A. Likewise, according to rule number 3, PM must be equal to BQ, or BQ equals to PM. BQ is equals to PM according to rule number 3, that the opposite sides of a rectangle are equal to each other. BQ equals to PM according to rule number 3. But we have already found out that BQ equals to A. So from this equation, A equals to BQ equals to PM, we'll conclude that PM is also equals to A. So we can write here that PM equals to A. So we actually found out that for the other one, PB, MQ is not a rectangle, but it is a square. Okay? And in the next step, we will focus on the right triangle, triangle ABC, the big right triangle, triangle ABC. We will implement the Pythagoras theorem on the right triangle, triangle ABC. If PT is a relation for Pythagoras theorem, so according to the Pythagoras theorem, in the right triangle, triangle ABC, we will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AB square plus BC square. According to the Pythagoras theorem, in the right triangle, triangle ABC, AC square equals to AB square plus BC square. What is the value of AC? AC, from the drawing, it is very easy to see that the value of diagonal AC equals to AR plus RC. AC equals to AR plus RC. Okay, AC equals to AR plus RC. But we have already found out that AR equals to 12 minus A. And AC is also equals to 12 minus A. So in conclusion, we found out actually that AC equals to 12 plus 12 is 24, minus A is minus 2A. So I write it down. We found out that AC equals to 24 minus 2A. So, according to equation number 1, AC square equals to AB square plus BC square. That is to say, AC is 24 minus 2A, so AC square is 24 minus 2A square. It equals to AB, AB is 12, so AB square is 12 square. Plus BC square. BC is also 12, so BC square will be equal to 12 square also. So in conclusion, we found out that according to equation number 1, 24 minus 2a square equals to 12 square plus 12 square is 2 times 12 square. Here we take a root out of this equation and we get that 24 minus 2a equals to the square root of 2, and the square root of 12 square equals to 12. Why? Because the square cancels the root and we left only with 12. So in conclusion, we found out that 24 minus 2a equals to 12 times square root of 2. Here we will add to this equation number 1, 2a, and we will also subtract square root of 2 times 12, and we will get that according to equation number 1, 2a equals to 24 minus square root of 2 times 12. Here we will divide equation number 2 by 2, equation number 1 by 2. Again, we will divide equation number 1 by 2. And we get that the value of a is equal to 24 over 2 is 12, minus 12 over 2 is 6. So in conclusion, this expression equals to 6 times square root of 2. So actually we found out that the value of a, that is the radius of this circle, is equal to 12 minus 6 times square root of 2 units. In the next step, we will define the radius of the semicircle as r. Here, dn is the radius of the semicircle because it starts from the center of the semicircle, that is to say from point N, and ends at point D, that is the point on this semicircle itself. Therefore, dn is the radius of this semicircle, and according to our definition, the radius of the semicircle equals to b, so dn will be equal to b. Likewise, nt is also the radius of this semicircle. Why? Because it starts from the center of this semicircle, that is to say from point N, and ends 97 nt ends at point T, that is a point on this semicircle itself. Therefore, nt is the radius of this semicircle, that is to say it equals to b units also. What is the value of tc? From the drawing, it is very easy to see that the value of line segment TC is equal to DC minus dN minus NT. Okay? From the drawing, it is very easy to see that TC equals to DC minus dN minus NT. So TC is equal to DC, that is 12 units, it is given as the question, minus dN, that is the radius of the semicircle, that is B, minus NT, that is also the radius of this semicircle, that is also B. So in conclusion, we found out that TC equals to 12 minus B, that is to say TC equals to 12 minus 2B. So we can write here that TC equals to 12 minus 2B. What is the value of SC or CS? The value of SC, it is very easy to see that the value of SC SC equals to RC minus RS. RC minus RS. I repeat again, RC minus RS equals to SC. It is very easy to see it from the drawing. So actually SC equals to RC. We already found out that RC equals to 12 minus A minus RS. We already found out that RS equals to A. So in conclusion, we found out that SC equals to 12 minus A, that is to say SC equals to 12 minus 2A. Okay, we can write here that SC equals to 12 minus 2A. In the next step, we will join points N and S together by a straight line. NS is the radius of this semicircle because of the fact that line segment NS starts from the center of this semicircle, that is to say from point N, and ends at point S, that is the point on this semicircle itself. And this is exactly the definition of a radius. Therefore, NS is the radius of this semicircle, that is to say it equals to B. And if the radius NS of this semicircle, it is drawn to point S, that is to say it is drawn to point S, that is the point of tangency of tangent AC with this semicircle. And whenever you have a radius that is drawn to the point of tangency, like in this case, then the tangent AC will be perpendicular to the radius NS. Tangent AC will be perpendicular to the radius NS or SN. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So because of the fact that triangle NSC has right angle and angle NSC is a right angle, therefore triangle NSC is a right triangle. So we can actually implement the Pythagoras theorem on the right green triangle NSC. We will implement the Pythagoras theorem on the right green triangle NSC. So we will implement the Pythagoras theorem on the right great triangle, triangle NSC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, NC square equals to SN square plus SC square. What is the value of NC? Here, from the drawing, it is very easy to see that NC, the hypotenuse NC, equals to NT plus TC. Again, NC, the hypotenuse NC equals to NT plus TC. So NC equals to NT, that is actually equals to B, the radius of the semicircle, plus TC, that is equals to 12 minus 2B. So here I found out that NC equals to B plus 12 minus 2B. That is to say, NC, the hypotenuse NC equals to 12, and B minus 2B is minus B. So in conclusion, we found out that the hypotenuse NC equals to 12 minus B. So NC square will be equal to 12 minus B square. And it equals to Sn square. Sn equals to B, so Sn square will be equal to B square plus Sc square. Sc equals to 12 minus 2a, so Sc square will be equal to 12 minus 2a square. So what is the value of 12 minus 2a? Here 12 minus 2a will be equal to 12 minus 2a minus 2 times a, and a equals to 12 minus 6 times square root of 2. So 12 minus 2a will be equal to 12 minus 24, minus and minus is plus, so plus 12 times square root of 2. So in conclusion, we find out that 12 minus 2a equals to 12 times square root of 2, and 12 minus 24 is minus 12. So in conclusion, we found out that 12 minus 2a equals to 12 times square root of 2 minus 12. So we can substitute 12 minus 2a in equation number 2 by, we substitute 12 minus 2a in equation number 2 here by 12 times square root of 2 minus 12. We'll do it now, and we will get that according to equation number 2, minus b squared, it is actually equals to 12 squared plus b squared minus 2 times 12 times b, that equals to b squared and we substitute the 12 minus 2a by 12 times square root of 2 minus 12 squared. So here we'll have plus 12 minus square root of 2 minus 12 squared here we have b squared in both sides of the equation, so b squared will get cancelled, and we'll get that 12 squared minus 2 times 12 is minus 24, so it is here 12 squared minus 24b, and here we have equals to 12. Here we will take 12 as a common factor out of this expression, so it will be 12. Inside the brackets we will have the square root of 2 minus 1 all squared. So we got that according to equation number 2, 12 squared minus 24b equals to 12 squared square root of 2 minus 1 is square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1. So we got that according to equation number 2, 12 squared minus 24b equals to 12 squared. So here we'll open the brackets. 12 squared times 2 is 2 times 12 squared plus 1 times 12 squared minus 2 times square root of 2 times 12 squared. Here we have 12 squared on both sides of the equation, so 12 squared will get cancelled, and what is left from equation number 2 after we cancel 12 squared, what is left is that in this side we have minus 24b equals to 12 squared is 144, 144 times 2 is 288, and here we have 12 squared, that is also 144, times minus 2 is minus 288, times square root of 2. Here we divide equation number 2 by 24, and we'll get that according to equation number 2 minus b equals to 188 over 24 is 12 minus 12 times square root of 2. So we found out that the value of b, first of all it is minus b, so we'll multiply equation number 2 by minus 1, and we'll get that according to equation number 2, b equals to 12 times square root of 2 minus 12 and we have already found out, according to question number 1, a equals to 12 minus 6 times square root of 2. We actually found out the values of A and B, that are the radiuses of the semicircle and the circle. So here A equals to 12 times square root of 2 minus 12, B equals to 12 times square root of 2 minus 12, A equals to 12 minus 6 times square root of 2, and A plus B here will be equal to, we have minus 12 plus 12 is 0, and we have 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that A plus B equals to 6 times square root of 2 units. So here, in the next step, we will join points M and R together by a straight line. MR is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and then at point R, that is a point on this circle itself. Therefore MR is the radius of this circle, that is to say it equals to A. And we have here the radius MR, it is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. Therefore, whenever you have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to the radius RM. Again, the tangent AC will be perpendicular to the radius RM, that is to say this angle will be equal to 90 degrees and this angle will be equal to 90 degrees according to rule number 2. Okay? In the next step we will do a construction from point M. We will draw perpendicular on Rm. Again, from point M we will draw perpendicular on Rm. So, we draw perpendicular from point M on Rm, that is to say, this angle will be equal to 90 degrees. In the next step, we will extend the radius NS until it intersects with the perpendicular from point M. And we will define the point of intersection of the perpendicular from point M and the extended NS as point X. NS is the radius of the semicircle, therefore it is absolutely a straight line. NS is a radius, it must be a straight line, and we extended the straight line NS by straight line. Therefore, we got line segment NX that is still must be a straight line, because when you extend a straight line by straight line, it still will stay a straight line. So we can write down that NX is a straight line, and x is a straight line. Okay, and x is a straight line, and we also have rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. And then rule number 4 again, according to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we found out that nx is a straight line. So if we focus on this side, of the straight line nx at point S, then the sum of the angles here must be equal to 180 degrees. Which angles we have at point S? We have here 90 degrees, and we have also angle RSX. In total, the sum of those two angles must be equal to 180 degrees according to rule number 4. Okay, the sum of the angles on this side of the straight line nx at point S must be equal to 180 degrees. That is to say 90 degrees plus the size of angle RSX must be equal to 180 degrees according to rule number 4. So here we'll subtract 90 degrees from this equation, and we'll get that angle RSX equals to 180 degrees minus 90 degrees is 90 degrees. Angle RSX equals to 90 degrees, so we can write here that angle RSX is a right angle. So actually in quadrilateral RMSX we have 1, 2, 3 right angles. In quadrilateral RSMX we have 3 right angles. The sum of 3 right angles is 270 degrees plus the size of the fourth angle, that is actually angle MXS, this angle. In total, the sum of those 4 angles inside quadrilateral RSMX must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, we'll subtract 270 degrees from this equation, and we'll get that the size of angle MSX, it is actually equals to 360 degrees minus 270 degrees, that is 90 degrees. So we found out that angle MSX is a right angle equals to 90 degrees. So actually we found out that quadrilateral RMXS has 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. Okay, so quadrilateral RMXS is at least a rectangle. I'll repeat again. Quadrilateral RMXS is at least a rectangle because of the fact that it has 4 right angles. And we have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, RM equals to SX. RM equals to SX according to rule number 3. I'll repeat again. In quadrilateral RMSX, RM equals to SX according to rule number 3 that the opposite sides of a rectangle are equal to each other. But we know that RM equals to 8 is the radius of the circle. RM equals to 8. So from this equation, A equals to RM equals to Sx, we will derive that Sx is also equals to A. So we can write here that Sx equals to A. Likewise, in rectangle MXRS, we know that RS must be equal to MX. RS must be equal to MX in rectangle MXRS, according to rule number 3. I'll repeat again. In quadrilateral RSMX, RS must be equal to MX according to rule number 3 that the opposite sides of a rectangle are equal to each other. But we have already found out that RS equals to A. RS equals to A. So from this equation, we will derive that MX is also equals to A. MX is also equals to A. X equals to A. So actually we found out that quadrilateral RMXS is a square. Why? Because all of its sides are equal to each other. And because of the fact that angle MXN is a right angle, triangle MXN is a right triangle, so we can implement the Pythagoras theorem on the orange right triangle, triangle MXN. According to the Pythagoras theorem, in the orange right triangle, triangle MXN, we will get, according to Pythagoras theorem, triangle MXN, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, The hypotenuse in the orange right triangle MXN is MN, so the square of the hypotenuse is MN squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to mx squared plus nx squared. I repeat again. In the right orange triangle MXN, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, mn squared equals to mx squared plus nx squared. Mn is the missing variable, the variable that we are looking for in this question, so we leave it as it is. Mn squared equals to mx squared. Mx is a, so mx squared is a squared plus nx squared. Nx is equal to a plus b. So nx squared will be equal to a plus b squared. So in conclusion, we found out that according to equation number 3, mn squared equals to a squared plus a plus b squared. And we have already found out the values of a, b, and a plus b. So we put the data inside the equation number 3 and we will find out the value of mn. So according to equation number 3, mn squared equals to a squared. A is equals to 12 minus 6 times square root of 2 squared plus, we have already found out that a plus b equals to 6 times square root of 2, so a plus b squared will be equal to 6 times square root of 2 squared. So here we will open the brackets on this side of equation number 3. A minus b squared equals to a squared, that is 12 squared, plus b squared, that is plus 6 times square root of 2 squared, minus 2 times a times b, plus 6 times square root of 2 squared is 6 squared is 36. Square root of 2 squared is 2, and 36 times 2 is 72. So we can find out that according to equation number 3, and it equals usually to mn squared. Here 12 squared is 144. 6 times square root of 2 squared is 72. Plus 72 minus 12. 6 times 2 is 12. 12 times 12 is 144. So it is minus 144 times square root of 2. That equals to mn squared. 72 plus 72 is 144. And 144 plus 144 is 2 times 144 minus 144 times square root of 2 equals to mn squared. Here we'll take a common factor of 144 on this side of equation number 3, and we will get that according to equation number 3, $144 is the common factor inside the brackets from this side, from this expression. What is left after we took from it 144 is a common factor. What is left is actually 2. What is left from this expression after we took from it 144 as a common factor? What is left is actually minus square root of 2, and it equals to mn squared. Here we'll take a root out of this equation, equation number 3, and we will get that the value of mn will be equal to the square root of 144, that is 12, times the square root of 2 minus square root of 2 units. We found out the value of mn. In terms of numbers, it equals to 9.18 units. So the answer to the question is that the length of mn, that is actually the distance between the centers of the semicircle and the circle, is equal to either 12 times square root of 2 times square root of 2 2 minus, it's really 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. In the next step, I'll summarize the lecture. Actually, we wanted to find out the distance between the center of the semicircle, that is point M, and the center of this circle, that is at point M, or the length of line segment MN. We have here a square ABCD. One side of this square equals to 12 units. Inside this square we have the semicircle and the circle. And also we have here diagonal AC. The circle is tangent to the square at point P and Q, and is tangent to the diagonal AC at point R, and the semicircle is tangent to diagonal AC at point S, and it is tangent to the square at point D, and it touches the square at point D on side DC of this square. And we want to find out the length of line segment MN. So actually, I presented to you a new rule. This is rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. Here we define PB as A. The length of two tangents from a common external point to a circle are equal. So, if we have a common external point, point P, And from point P we draw two tangents to this circle. The first tangent is PA, the second tangent is PB, then the length of those two tangents will be equal to each other. That is to say, PA will be equal to PB according to rule number 1. Okay, then we implemented rule number 1 in our drawing. We have at point B, we have from the external point B, we have two tangents to this circle. We have tangent BP and tangent BQ according to rule number 1. They are equal to each other. That is to say, BP is equal to BQ, but according to our definition, BP equals to A. From this equation, A equals to BP equals to PB, we will conclude that BQ is also equals to A. So here we found out that BQ equals to A. And what is the value of AP? AP equals to AB minus PB. AP equals to AB minus PB. That is to say, AP equals to AB, that is 12 units. And BP equals to A. So in conclusion, we found out that AP equals to 12 minus A. Line segment AP equals to 12 minus A. Likewise, the value of line segment CQ will be equal to BC minus BQ. CQ, QC equals to BC minus BQ. BC equals to 12, BQ equals to A. So in conclusion, we found out that QC equals to 12 minus A. Then we focused on point A, the external point A. From the external point A, we have two tangents to this circle. The first tangent is tangent AP. The second tangent is tangent AR. And according to rule number 1, they must be equal to each other. That is to say, here AP equals to AR, according to rule number 1. But we have already found out that AP equals to 12 minus A. From this equation, 12 minus A equals to AP equals to AR. We conclude that AR is also equals to 12 minus A. If AR is also equals to 12 minus A. And then we focused on point A. From the external point A, we have two tangents to the semicircle. The first tangent is tangent AD. The second tangent from point A to this semicircle is point AS. And according to rule number 1, those two tangents must be equal to each other. That is to say, AD equals to AS. Again, according to rule number 1, AD equals to AS. But AD is one side of square ABCD, that is to say it equals to 12 units. So from this equation, 12 equals to AD equals to AS, we conclude that AS is also equals to 12 units. Here we can write down that AS equals to 12 units. And what is the value of RS? It is very easy to see from the drawing that RS equals to AS minus AR. Okay, RS equals to AS minus AR. AS, we just right now found out that AS equals to 12. We have already found out that AR equals to 12 minus 2A, so in conclusion we found out that RS equals to 12 minus A. We open the brackets here and we found out that RS equals to 12 minus 12 plus A. So in conclusion, we found out that RS equals to A units. Then we focus on point C. From point C, we have two tangents to this circle. From the external point C, we have two tangents to this circle. The first tangent is CQ. The second tangent is CR. But according to rule number 1, they must be equal to each other. Here, CQ must be equal to CR according to rule number 1, but we have already found out that CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR, we will conclude that CR is also equals to 12 minus A. Here we can write down that CR equals to 12 minus A. Okay? Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here we have the center of this circle is this point O, and we have tangent AB that is tangent to this circle at point M. Point M is the point of tangency. OM is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point O, that is the center of this circle, and ends at point M, that is the point of this circle itself. Therefore OM is the radius of this circle. And we have the radius OM that is drawn to the point of tangency. That is to say, it is drawn to point M, that is the point of tangency of tangent AB with this circle. So whenever you have a radius that is drawn to the point of tangency, like in this drawing, then the tangent AB will be perpendicular to MO. Again, the tangent AB will be perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. This is rule number 1. We implemented rule number 2. We implemented rule number 2 in our drawing. We join points P and M together by a straight line. PM is the radius of this circle. Why? Because it starts from the center of this circle, that is to say from point M, and that's at point P, that is a point on this circle itself. Therefore PM is the radius of this circle. And the radius PM is drawn to the point of tangency, that is to say it is drawn to point P, that is the point of tangency of tangent AB with this circle. So whenever you have a radius that is drawn to the point of tangency, then the tangent, here, tangent AB will be perpendicular to the radius PM. Again, the tangent AB will be perpendicular to the radius PM. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, MQ is also, we join points M and Q together by a straight line. MQ is the radius of this circle because it starts from the center and ends at point Q, that is the point on the circle itself. And we have here the radius MQ, it is drawn to the point of tangency, that is to say it is drawn to point Q, that is the point of tangency of tangent BC with this circle. So whenever you have a radius that is drawn to the point of tangency, then the tangent BC will be perpendicular to the radius QM. Again, the tangent BC will be perpendicular to the radius QM. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So we actually found out that in quadrilateral PBMQ we have 3 right angles. 1, 2, 3. And the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the 4th angle, that is actually angle PMQ. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. I repeat again. In quadrilateral PBMQ, we have 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the 4th angle, that is actual angle PMQ. In total, the sum of those 4 angles must be equal to 360 degrees. We subtract the 270 degrees from this equation and found out that angle PMQ equals to 90 degrees. So this angle equals to, this angle PMQ equals to 90 degrees. And therefore, we actually found out that quadrilateral PBMQ has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is, according to rule number 3, that is to say PM equals to MQ. Okay, here, quadrilateral PBMQ is at least a rectangle because it has 4 right angles, and we have rule number 3 that states that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle PBMQ, PB must be equal to MQ, according to rule number 3. But we know that PB equals to A according to our definition. From this equation, we will conclude that MQ is also equals to A. MQ is also equals to A. So MQ is the radius of this circle. So we found out that the radius of this circle equals to A units. Likewise, according to rule number 3, BQ must be equal to PM, according to rule number 3, but we have already found out that BQ equals to A. From this equation, A equals to BQ equals to PM, we will conclude that PM is also equals to A. PM is also equals to A. So we actually found out that quadrilateral PBMQ is a square. Why? Because all of its sides are equal to each other. Okay? Then, actually, we know that angle ABC is a right angle because of the fact that all of the angles inside the square are right angles. All the angles inside square ABCD must be equal to 90 degrees. That is to say, angle ABC is a right angle. Therefore, triangle ABC is a right triangle. We implemented the Pythagoras theorem of the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC. The square of the hypotenuse is AC square. It must be equal to the sum of the squares of the perpendiculars. That is to say, it equals to AB square plus BC square. Then we found out the value of AC. It's very easy to see that the value of diagonal AC equals to AR plus RC. We have already found out that AR equals to 12 minus A, and RC is also equals to 12 minus A. So in conclusion, we found out that AC equals to AR plus RC, that equals to 12 minus A plus 12 minus A. 12 minus A plus 12 minus A. 12 plus 12 is 24, and minus A is minus 2A. So in conclusion, we found out that AC equals to 24 minus 2A. So we can substitute AC by 24 minus 2A. So AC square will be equal to 24 minus 2A square. That equals to AB, that is 12, so AB square is 12 square, plus BC, that is also 12, so BC square is also 12 square. So 24 minus 2A square equals to 12 square plus 12 square is 2 times 12 square. We took a root out of this equation, equation number 1, and we found out that 24 minus 2A equals to the square root of 2. And here we have this, the root of 12 square is 12. Why? Because the root cancels the square and we're left only with 12. So in conclusion, we found out that according to equation number 1, 24 minus 2A equals to square root of 2 times 12. Here we added to this equation 2A and then we subtracted square root of 2 times 12, and we found out that according to equation number 1, 2A equals to 24 minus square root of 2 times 12. We divided this equation, equation number 1 by 2, and we got that A, the radius of the circle, equals to 12, because 24 over 2 is 12, and 12 over 2 is 6. So in conclusion, we found out that A equals to 12 minus 6 times square root of 2 units. Then we defined the radius of the semicircle as B. That is to say, dn equals to B and T is also equals to B. And we joined points N and S together by a straight line. And S is the radius because it starts from the center of the circle, and S at point A. S, that is a point on the semicircle itself. Therefore, NS is the radius, that is to say, it equals to B. And the radius NS is drawn to the point of tendency, that is to say, it is drawn to point S, that is the point of tendency of tangent AC with this semicircle, and whenever you have a radius that is on to the point of tendency, then the tangent AC will be perpendicular to the radius Sn. Again, tangent AC will be perpendicular to the radius Sn. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Therefore, the green triangle NSC is a right triangle, so we can implement the Pythagoras theorem on the right green triangle NSC. But first of all, because of the fact that dn equals to b and nb is also equals to b, and t is also equals to b, then tc will be equal to 12 minus b, that is to say tc equals to 12 minus 2b. Okay? Again, tc equals to dc minus nt minus tn. This is to say tc equals to dc, that is 12, minus dn, that is b, minus tn, that is also b. In conclusion, we found out that tc equals to 12 minus 2b. Then we found out the value of SC. The value of line segment SC is very simple to see from the drawing, that SC equals to RC minus RS. Again, SC equals to RC minus RS. We have already found out that RC equals to 12 minus A, RS equals to A, so in conclusion we found out that SC equals to 12 minus A minus A, that is to say SC equals to 12 minus 2A. Then we implemented the Pythagoras theorem on the right green triangle NSC. The hypotenuse is NC, that is to say the hypotenuse NC equals to NT plus TC. The hypotenuse NC of the green right triangle equals to NT plus TC. NT is B and TC is 12 minus 2B. NC equals to 10 plus T here. So it is NT is B, TC is 12 minus 2B. So NC equals to 12 and B minus 2B is minus B. So in conclusion, I found out that NC equals to 12 minus B, and according to the Pythagoras theorem, NC squared equals to SC squared plus SN squared in the right triangle NCS, the green right triangle. So NC squared is 12 minus B squared, that equals to Sn square is B squared. Yeah. Sn square is B square, and plus Sc square is 12 minus 2A square. 12 minus 2A square. And then we found out the value of 12 minus 2A. 12 minus 2A equals to 12 minus 2, and A equals to 12 minus 6 times square root of 2. And 2 times 12 is 24. And 2 times minus 6 is minus 12. So in conclusion, we found out that here 12 minus 2A equals to 12 times square root of 2 minus 12. Here 12 minus 24 is minus 12, and we have also here 12 times square root of 2. So in conclusion, we found out that 12 minus 2A equals to 12 times square root of 2 minus 12. So we can substitute 12 minus 2A by 12 times square root of 2 minus 12. We did it, and we got that here we open the brackets, 12 minus 2a is 12 times square root of 2 minus 12. So here we have equation number 2 that states that 12 minus 2b, 12 minus b square is equals to 12 square plus b square minus 2 times 12 times b, and it equals to b square, and 12 minus 2a is 12 times square root of 2 minus 12 square. So here we have 12 square, we have b square on both sides of the equation, so b square will get cancelled. And what is left from equation number 2 after we cancel b square, what is left, it is actually 12 square, and minus 2 times 12b is minus 24b. And here we took 12 as a common factor, so inside the brackets, what is left from 12 times square root of 2, what is left is square root of 2. And what is left from minus 12 after we took from it 12 as a common factor, what is left, it is actually minus 1, and all squared. Okay, so here we have 12 square minus 24b equals to 12 square, and we open the brackets here. Actually, we did the calculation of square root of 2 minus 1 squared, that is 2, plus 1 minus 2 times square root of 2. So we got that 12 square minus 24b. We open the brackets here, and we got the 2 times 12 square plus 1 times 12 square minus 2 times square root of 2 times 12 square. We have 12 square on both sides of the equation, so 12 square will get cancelled. So in conclusion, we found out that minus 24b equals to 12 square is 144, 144 times 2 is 188. Here also 12 square is 144, minus 2 is minus 188. So in conclusion, we found that according to equation number 2, minus 24 b equals to 288 minus 288 times square root of 2. We divided equation number 2 by 24, and we got that minus b equals to 288 over 24 is 12, and minus 288 over 24 is minus 12. So in conclusion, we got that minus b equals to 12 minus 12 times square root of 2. We multiplied the equation number 2 by minus 1, and we found out that according to equation number 2, b equals to 12 times square root of 2 minus 12. We have already found out that a equals to 12 minus 6 times square root of 2. And here a plus b, what is the value of a plus b? Here we have minus 12 plus 12 is 0. And 12 times square root of 2, 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2. Okay? And then we did a construction. First of all, we joined points M and R together by a straight line. So MR is the radius of this circle. Why? Because it starts from the center of the circle and ends at point R, that is a point of this circle itself. Therefore MR is the radius of this circle, that is to say it equals to A. And we have the radius MR that is drawn to the point of tendency. That is to say the radius MR, it is drawn to point R, that is the point of tendency of tangent AC with this circle. So whenever we have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to the radius RM. Okay? The tangent AC will be perpendicular to the radius RM, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Then from point here, from point M we do perpendicular on RM, that is to say this angle equals to 90 degrees, and we extended NS until it intersects with the perpendicular from point M. We define the intersection point between the perpendicular from point M and the extended NS as X. So in quadrilateral, and then here we have NS is the radius, and as radius must be a straight line, and when we extended the straight line NS, that is the radius, by a straight line, then we got NX, that it still must be a straight line, because when you extend a straight line by a straight line, it still will be a straight line. That is to say, NX is the straight line, and we have rule number 4 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if you focus on this side of the straight line NX at point S, then the sum of the angles must be equal to 90 degrees. Which angles we have at point S? On this side, we have 90 degrees plus angle RSX. In total, the sum of those two angles must be equal to 180 degrees. 90 degrees plus angle RSX must be equal to 180 degrees according to rule number 4. We subtracted 90 degrees from this equation, and we got that angle RSX equals to 90 degrees. This angle equals to 90 degrees. So we actually found out that in quadrilateral RMSX we have 1, 2, 3 right angles. Okay, so the sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is actually angle MXS. In total, they must be equal to 360 degrees. Okay, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, we subtracted 270 degrees from this equation, and we found out that angle MXS or SXM, which is the same, equals to 90 degrees. This angle equals to 90 degrees, therefore quadrilateral RMXS has 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, and we know that the opposite sides of a rectangle are equal to each other. Okay, quadrilateral RMXS is at least a rectangle, and the opposite sides of a rectangle are equal to each other according to rule number 3. That is to say, RM equals to SX. Okay, Rm equals to Sx according to rule number 3. But we know that Rm is the radius of this circle, that is to say it equals to A. So from this equation, A equals to Rm equals to Sx, we will conclude that Sx is also equals to A. Here Sx equals to A. Likewise, in rectangle RMSX, Rs must be equal to Mx. Rs must be equal to Mx, but we have already found out that Rs equals to A. So from this equation, A equals to Rs equals to Mx, we conclude that Mx is also equals to A. Here, Mx is also equals to A. And because of the fact that angle MXN is equal to 90 degrees, then the orange triangle is a right triangle, that is to say triangle MXN is a right triangle. So we can implement the Pythagoras theorem on the right triangle, triangle MXN. According to the Pythagoras theorem, the square of the hypotenuse is mn squared. It must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to mx squared plus nx squared. Mn squared equals to mx squared plus nx squared. So mn squared equals to mx. Mx is a, so mx squared is a squared, and nx is a plus b. Here we know that here nx is a plus b, so nx squared is a plus b squared. So the conclusion found out that according to equation number 3, mn squared equals to a squared plus a plus b squared. A equals to 12 minus 6 times square root of 2, so a squared is 12 minus 6 times square root of 2 squared. A plus b is 6 times square root of 2, so a plus b squared is 6 times square root of 2 squared. So 12 minus 6 times square root of 2 squared equals to 12 squared plus 6 times square root of 2 squared minus 2 times 12 times 6 times square root of 2 plus 6 times square root of 2 squared equals to 72. Here 12 squared is 144, 6 times square root of 2 squared is 72, minus 2 times 6 is 12, 12 times 12 is 144, times square root of 2, so this expression equals to 144 times square root of 2, that equals to mn squared. Here 72 plus 72 is 144, 144 plus 144 is 2 times 144, so we got that 2 times 144 minus 144 times square root of 2 equals to mn squared. So here we took 144 a common factor out of these two expressions, so inside the brackets what is left from this expression after we took from it 144 as a common factor, what is left is actually 2. What is left from this expression after we took from it 144 is a common factor, what is left is actually square root of 2, so conclusion is found out that 144 times 2 minus square root of 2 equals to mn squared. We took a root of this equation, question number 3, and we found out that the square root of 144 is 12, and times the square of 2 minus square root of 2 squared. So mn equals to either 12 minus square of 2 minus square root of 2 units, or in terms of numbers, mn equals to 9.18 units. Okay, again, the distance between the center of the semicircle that is n and the center of this circle that is n, that is to say the length of nn, is equal to either 12 times square of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. Okay, thank you very much.